Welcome to Math Understood, and today we are going to be learning how to calculate the area of a parallelogram. The following are some concepts that are helpful when calculating the area of a parallelogram. We have height, which is a line segment drawn to form a right angle with one side of a shape, as we can see here in this diagram and here in this diagram. And the base is the side of a shape that is measured to calculate the area or perimeter of the shape. Any side of a shape can be the base of the shape. So here is the base, but the base could also be here, here, or here. And on this diagram, the base is here, but it could also be here, here, or here. So this is a dilemma I have. Do these two shapes have the same area? As we can see, the square has 15 centimeters on all sides. And for our rhombus, we have 15 centimeters on all sides. One way we can solve this problem is by cutting the rhombus along its height and moving the rectangular piece as shown. As you can see from the diagram below, when we cut and move it over, we now get a complete rectangle. This is also known as conservation of area, and this is crucial to remember as we move forward. An object retains its size when the orientation is changed or when it is broken into smaller parts and the parts are rearranged, as we did with this example. It's important to recognize that the area of a parallelogram is the same as the area of its related rectangle. You should be able to determine the base or the height given the area and other dimensions, and recognize that a variety of parallelograms can have the same area. So now that we know that a parallelogram has the same area as its related rectangle, and a rectangle's area is equal to base times height, this is how we will also calculate the area of a parallelogram. This is the first example we're going to be doing as we calculate the area of a parallelogram. When calculating the area of a parallelogram, it's important to identify our base, which is 5 centimeters, and our height, which is 2.4 centimeters. When calculating area, we times our base, which is 5 centimeters, by our height, which is 2.4 centimeters, which gives us a value for our area equal to 12.0 centimeters squared. Now it's important to include to one decimal place because our base and our height has been given to one decimal place. It's also important to include centimeters squared because this indicates that it's the product of two dimensions, base and height. So this is the second example we're going to be doing for calculating the area of a parallelogram. We need to identify our base, which is 3 centimeters, and our height, which is 4 centimeters. So for calculating our area, we're going to go area is equal to our base, which is 3 centimeters, times by our height, which is 4.0 centimeters, and our area equals 12 centimeters squared. Now again, we've included to one decimal place because our base and our height has been given to us in one decimal place, and we've also included centimeters squared. For the next example, I would like you to try and solve this one on your own first. So I would like you to pause the screen and work through it. Now that you've had some time to work through this example, we're going to do it together. So again, it's important to identify our base, which is 16 centimeters, and our height, which is 19 centimeters. So for calculating our area is equal to 16 centimeters times by the height, which is 9 centimeters, which gives us an area equal to 144 centimeters squared. Now for this example, we didn't include any decimal places because our base and our height have no decimal places, but we still did include our centimeters squared. So for our last example, I would also like you to try this on your own. We are going to be calculating the area of the parallelogram WXYZ using two different bases. So I would like you to pause the screen and work through this example. Now that you've had some time to work through this example, we're going to solve it together. The first one I'm going to use is a base of 6 centimeters with a height of 3.9 centimeters. So when solving for this area is equal to 6.0 centimeters times by 3.9 centimeters, which gives us an area equal to 23.4 centimeters squared. Now again, it's important to recognize I included to 1 decimal place because our base and our height is to 1 decimal place, and I included centimeters squared. I'm now going to calculate the area of the parallelogram using a different base than the previous. So my base for this one will be 4.5 centimeters and my height will be 5.2 centimeters. So when calculating, area is equal to 4.5 centimeters times by 5.2 centimeters, which gives me an area equal to 23.4 centimeters squared. And again, I included to 1 decimal place because the base and the height were to 1 decimal place, and I included centimeters squared.